Okay, in this lesson we are going to talk about multiplication and division of sets. We've already considered the addition and subtraction. Now the following three rules can help us with the multiplication and division of sets. The first one is this: root A times root B is root AB. Okay, so this times this is multiplying them under the same square root. Okay, another one is root A divided by root B is all of them under the same square root, A over B. And then the third one is this: root A times root A gives us root A square, and then any number under a square root, which is square, is basically the number itself. And so root A times root A is root A square, which is A. Now these two also really help. Root AB times root CD will be equal to AC root BD. And this, what happens, you take the ones outside the set, then you multiply them. So A and then C, you multiply them. And then the ones under the square root, you also multiply them together. So A root B times C root D becomes AC root BD. Then this also happens when it comes to division. You take the ones outside the set, you divide them, and then the ones inside the set, you divide them under the square root or under the square root. Alright, so A root B divided by C root D becomes A over C root B over D. As always, examples are the best way to understand this, so let's get right into it with examples. If we have square root of 5 times square root of 2, then we have square root of 5 times 2, like the rule depicted. And so 5 times 2 is 10. That is the answer. Square root of 5 times square root of 2 is square root of 10. Then square root of 3 times square root of 7 is 7 times 3, all under the square root, which is square root of 21. How about division? Let's see. Square root of 12 divided by square root of 6 is square root of 12 over 6, and 12 over 6 is 2, right, under the square root. You don't forget the square roots. Okay, what about square root of 24 divided by square root of 4? Now we know 4 divides 24 6 times, right? So that is it. We just replicate it under a square root. So 4 cancels 24 6 times. We bring our square root. So this is how we operate sets, by multiplying and then dividing them. Okay, let's see some other examples as well, which are a bit more complex than the first one. Okay, so if you have 4 root 12 over 2 root 2, how do you go about this? You recall that this is already arranged in the form A over C and then B over D already. And so with this, you know the 2 cancels 4, and then the 2 under the set also cancels the 12. So this is what eventually happens, and we get 2 root 6. This cancelled this 2 times, and then this cancelled this 6 times, and we recall that these two are under a square root, and so we repeat the square root. Alright, how about this example? How do you go about this? You can tell this needs to be simplified. It is large enough to be simplified, and truly we can simplify it to be 3 times 9. 3 times 9 gives us 27. So instead of writing the 27, we rather replicate it using this multiplication. And now once you spot 9, you know that it is 3 squared. We can rewrite everything to square root of 3 plus square root of 3 times square root of 3 squared. Right? This is what we've done. We repeat the square root of 3 here. Now these two, we separate them. So the square root of 3 is this, and then the square root of 9, we rewrite it as 3 squared, and that is what we have here. And so all of this expression is what we have here. We've just taken the 9 and then represent it as 3 squared. Good. Now from here, we know that the square root of 3 squared becomes 3, right? So this is everything we have now. This is everything. Just that this now becomes this. Every number under the square root which is squared is a number itself, because the square cancels the square roots in this manner, and that is what we have here. So with this, we can go further and then say everything becomes square root of 3 plus 3 root 3. 3 times root 3 is 3 root 3 plus the root 3, and that is what we have here. We don't forget it is over 2. Now from here, we can see that we have root 3, we have root 3. They are like terms, and so we can add them, right? So we have 4 root 3. Like we said earlier, a common mistake is to forget that there is 1 here, or this is 1 root 3, which we don't write the 1. And so root 3 plus 3 root 3 is basically 1 root 3 plus 3 root 3, and 1 plus 3 is 4, and that is why we have 4 here. So 4 root 3 over 2. We can go further because we have 2 here, we have 4 here, which can cancel, and so 2 cancels 4 2 times, so we have 2 root 3, because this 2 cancelled this 4. This is the final answer to the question we were given here. Okay, let's see some more examples. Like 2 roots 3, square root of 2 plus 3 plus 2 root 3 in this form. You can see this has a distributive property. We can multiply this by this, and then we take this one and multiply by this as well. And so let's go ahead and do it. Okay, so we have 2 times square root of 2 times 3, and that is what we have here. Square root of 2 times 3 is this. Then we take this and multiply by this as well. Square root of 2 times square root of 2. That is what we have here. Because you have the plus sign, we just bring it down here. 3 times root 2 is 3 root 2 plus 2 root 2 is root 2 square root of 2 squared. Square root of 2 squared, like this. This becomes this. And we know what that means. It means this becomes 2. Any number under a square root that is squared becomes the number itself. Don't forget. Right. So we just repeat everything, simplifying it further. This now becomes this. We can't go any further because this is square root here and there is no square root here. So this is the final answer to our question. Let's try another one which is similar to this and see. Square root of 3 minus 1 times square root of 3 plus 1, difference of 2 squares. How do we go about this? Okay, now to go about this, we take this, multiply by all of this, then we take this and multiply by all of this, and this is how it will look like. This and that, and then this and that as well. And so this time this gives us root 3 times root 3. Now this also goes with this. Initially this multiplied this, and now this is multiplying this. This is what we get out of it. Root 3 times 1. Then we look at this one multiplying the 2 here. So 1 times root 3. Now we are bringing the negative here because the 1 is negative. Again, the 1 1 will multiply the 1 here. Okay, that is negative 1 times 1. So we took this, multiplied by this, took this, multiplied by this, took this and multiplied by this one, then these two also multiplied. And that is the expression we have here. Okay, now that we have this, we can multiply root 3 times root 3, and that is root 3 squared, and we know what that will become of even before we go further. Plus root 3 times 1, that is root 3, minus 1 times root 3, that is also root 3, and then 1 times 1, that is 1, minus 1 times 1. Good. From here we can see something. This and this can go because this is positive and this is negative. We cancel them out from here, and we know what happens to root 3 squared. It becomes 3 minus 1, which is 3 minus 1 is 2, and that will be the final answer. Great. So this is how we go about multiplication of SID. There is a relatively more complex one which will prolong this video, so watch out for the next video as we look at that. We'll make sure take you through how to use the prime factorization method to work that one out. So make sure you watch the next video to get an understanding of more complex set, which involves both addition and then division and subtraction, all of it combined basically. So make sure you check the next video out.